Hello, class, and welcome to today's lesson on 9.5, sorry. We're going to talk about something called dilations. Our objective today is to understand dilation images of figures, and then our essential question is, what is a dilation? So this is kind of showing a real-world example here. We have our normal pupil here, our normal iris, and then what happens is once it's given less light, right, our pupil expands, and this is a form of a dilation. It dilates, right? You might hear about a pupil dilating, and so we're going to talk about it mathematically here today. So to start, what is a dilation? A dilation has some center point. One of the key things we use with dilation is something called scale factor, where n is greater than 0. Right? What's really happening to this is, right, we have our black triangle. It is dilating. In this case, it is getting larger. It is getting larger. We're going to talk about the two kinds of dilations we can have. But it is getting larger, but it's the same figure. So, right, if we think back to that, one of those first vocab words, an isometry, right, a dilation is not an isometry because the size of the figure is going to be changing. So our two examples here, right, first one, a dilation is an enlargement if the scale factor is greater than 1. The dilation is a reduction if the scale factor is between 0 and 1. So if we look at this first figure here on the left, notice we have our original figure. This side is 2. This side is 4. So we're trying to figure out, okay, from our original, our pre-image, to our image, what's happened? Well, we've gone from a 2 to a 4. So notice we're thinking to ourselves, what do I have to multiply 2 by to get to 4? Well, 2 times 2 gets us to 4, so that's how we find our scale factor. Then for reduction, right, similar idea here, black figure, this side is 8, this side is 2. What do I have to multiply 8 by to get to 2? Right, you could think divide by 4, but we want to put it in terms of multiplication, so we're really multiplying by 1/4. So notice this is an important piece right here. Right, enlargement has a scale factor that is greater than 1. A reduction has a scale factor that's between 0 and 1. Between 0 and 1. So first example here, right, as we're looking here, I'm going to grab the pen tool real quick. So, right, we're looking, J prime, K prime, L prime, M prime is a dilation of JKLM. The center of dilation is O. Is the dilation an enlargement or reduction? And what is the scale factor? So, right, we start with the black image, we go to the blue. So right away, we should be able to look at this and go, okay, it's going to be a reduction. So we know it's going to be between 0 and 1. Right, our scale factor is going to be somewhere in between 0 and 1, except, sorry, shouldn't have done this, right? It's not equal to, it has to be greater than or less than symbols. So now that we have this, what we need to figure out, right, make your life as easy as you can, right? I'm going to focus on the line that's straight on one of these ones that I can count. Right, these other ones I'd have to use distance formula to figure out, which we'll have to do sometimes. Right, this one here, I can just count. This is 1, 2, 3, 4. And now we go from 4, and now if we go to this figure, notice we have 1, 2. And so our question is, what's our scale factor to get from our original, our black image, to our blue? Right, our scale factor would be 1/2. 1/2. So next one here, it says, what are the images of vertices PSG for a dilation with a center of 0, 0 and a scale factor of 2? So, right, what it means to have a scale factor of 2, right, we're multiplying all of our sides by 2. What we can do, in fact, if we're just given the actual points here, we can actually multiply each point. Notice right here, talking about it, right, we can multiply our x value by 2, our y value by 2, and find all of our new points. So starting here, right, with P, if I take P, our original point of 2, 0, and I multiply both of those numbers by 2, right, notice I get this new point at 4, 0. Okay, now let's do the same thing, but with z, right? Negative 3, 1. Well, now, right, we have our new point at negative 6, 2. And then last one, of course, right, point G was at 0, negative 2. It is now going to be at 0, negative 4. So notice all we did was multiply our x value by 2, our y value by 2 for all three of our points, and we came up with our dilation. And right, so if we look at this one, right, we should be able to tell just by the scale factor, right, this would be an enlargement, right? We enlarged our original image. Notice because our scale factor is greater than 1. So one more example here. It says, what are the images of the vertices PSG for a dilation, PZG, for dilation with center 0, 0, a scale factor of 1/2. So, right, we look at our original points, right? Same points that we had before. And so now if we look at P, right, P is at 2, 0. Z is at negative 3, 1. And G is at 0, negative 2. So what we need to do, just like we did on the problem before this one, instead of multiplying both x and y by 2, we're going to multiply them both by 1/2. And so now if we look, our new value for p, right, if we take 2 times 1/2, right, if we do 2 times 1/2, we get 1. 0 times anything would just be 0. So our new point for p is at 1, 0. For z, right, it's going to be at negative 1.5, 0.5. All right, so we got to be aware of those ones when they're odd numbers, right? We might deal with some decimals here. And then g is going to be at 0, negative 1. So if we were to plot these points now, right, I'll do this in blue. So right, 1, 0, this is now p prime. Z is at negative 1/2, 1/2. And that is Z prime. And then last one, G, right? G is going to be at 0, negative 1. And there is G prime. So right now, notice we have gotten our points. And if we want to, I'll just do this real quick. Connect our points together. There is our image, our dilation. And right, notice in this case, so I'll just change this to blue real quick. Right, in this case, our dilation was in fact a reduction, right? We reduced the size of our figure specifically by a scale factor of 1/2. So that is it for today's lesson on 9.5, talking about dilations.